Hi guys, welcome to our third video in chapter 21. This is going to cover section 3, which is all about electrolysis. So let's get started with it, right? Our objectives here are pretty straightforward. This is the video where we want to see how to reverse a spontaneous reaction, right? So we're going the other way now, in an electrochemical cell, and we want to compare electrolysis of sodium chloride to the electrolysis of brine to see what similarities and differences we have, right? So let's jump right into it. Our first section is called reversing redox reactions, and that is because electrolysis is defined as the use of electrical energy to bring about a chemical reaction. Now, these types of reactions are not spontaneous. That is why we need to use electricity to power the reaction, to make it go forward. We need to actually plug it into the wall and get electricity in there to make it happen. An electrolytic cell is an electrochemical cell in which electrolysis occurs. So we can see we have two examples, right? This is our typical galvanic cell, also known as a voltaic cell. That's what we first talked about with our spontaneous redox reactions. And you can see that in this reaction, we have an oxidation and a reduction reaction where our G is less than 0, meaning this is a spontaneous process. Okay, so this happens all on its own. We put the anodes into our electrolyte, and we put a wire up, and we can see the electricity pass through and do work by lighting up the light bulb. Now, what we are more focused on here is our electrolytic cell, where we look at using energy to drive a non-spontaneous redox reaction. Okay, so maybe we actually want to go the other way. Maybe we want to cause some, maybe we want to make like solid sodium precipitate out of this, or maybe something like that. We want to collect some non-spontaneous product here. Well, our oxidation reaction is going from our negative Z to a Z with a free electron, and the reduction of our positive Y to a neutral Y. You can see this overall reaction here. It looks pretty similar to our galvanic cell, except now it's the reverse reaction. We go from the ions to the atoms, and here delta G is greater than 0, which means it is not spontaneous. So this only occurs because we have this electrical circuit. We have this energy, this electrical energy being used to power this process. So again, that is called an electrolytic cell. Now, we have several applications of this electrolytic cell that we use across industry to make materials. The first example is the production of solid sodium chloride. It's called the electrolysis of molten sodium chloride. So they have these reactors where we take sodium chloride and it is put into our system that heats it up to very, very high temperatures, somewhere over 900 degrees Celsius, which causes our sodium chloride to melt. And then that molten sodium chloride, we pass a current through it. We have our cathode here. We have our anode here. We pass an electric current through our molten sodium chloride, and this causes an electrolytic reaction, right? It causes the reverse, so it causes our sodium chloride to go through the process of converting from sodium chloride into solid sodium and chlorine gas. And you can see I actually wrote out the chemical reaction above here. So you can see this process is not spontaneous, but this is what's going on in our electrolytic chamber here because we have passed this electricity through it and we've set up an electrolytic cell. So again, going from sodium chloride, which is molten in the liquid state, to solid sodium and chlorine gas, which the chlorine gas evolves out of the top of our reactor. Now that is how we produce things like solid sodium to be used like in lab and demonstrations in an industry. It's also where we get chlorine gas. We also can use electrolysis to produce some valuable materials from brine. Brine being very salty water. So you can see in this brine setup, we have our anode on the left, we have our cathode on the right. And so the electrons are going from anode to cathode here. And we start with dissolved sodium chloride. So we have sodium chloride in water. We pass this electrolytic cell through, and we evolve chlorine gas, hydrogen gas, and we form sodium hydroxide as a byproduct. But this is a very useful way for us to produce a valuable product called hydrogen gas that is typically done through the electrolysis of brine. right? And this hydrogen gas could be a source of fuel for something like a fuel cell. And the last one I want to talk about is actually the electrolysis of aluminum, a fairly complex process. You can see set up here. Our reactant is actually a pretty complicated aluminum oxide and a sodium aluminum hexafluoride. So it's a pretty crazy looking reactant. We put this in here. We use a carbon anode, which is just carbon, pass some electricity through this, and we actually see metallic aluminum comes out as our product. So that's how we extract aluminum from aluminum, or again, it's done using electrolysis. All right, guys, that's all I have for this video. Thank you for watching, and I'll see you in the next one.